Welcome to our fourth lesson, and today's topic is Introduction to Kinematics. And kinematics simply means fancy word for motion. All right, so we're talking about the study of motion. So what do I want you to be able to do after this lesson? Well, I want you to be able to explain the basic concepts involved with kinematics, and then I want you to be able to solve some of the problems. We get into some introductory problems related to real-world applications. So we gotta get rid of the boring stuff first, definitions, because when I use a term or definition, very important that you are able to understand what I'm talking about. So the first one is distance, which is something that you're very familiar with. So distance is how far an object has moved, regardless direction. Okay, so that means that we are dealing with a scalar. This is a scalar, and the example is 30 kilometers. Okay, so distance is a measure of how far you've traveled. Doesn't matter, could be going forward plus going backward. All right, so direction, if I went 10 kilometers forward, then I went 10 kilometers backward, you would tell me that you traveled 20 kilometers. Okay, what makes it a little bit complicated is when we talk about displacement. Displacement is how far an object has moved from its starting point. All right, so this is a vector. And that's what we were working on the last couple days. So 30 kilometers, but now I need a direction. I moved 30 kilometers east. If I look at that example I just did, if you drove 10 kilometers to school, and then that night you came back and drove 10 kilometers home, what is your displacement? Your displacement is 0 because you are back at your starting point. So your daily displacement, if you think of it this way, when you wake up and get out of bed, if you return back to bed every night at your house, your daily displacement is always 0. The distance you've traveled is not 0. The distance, it's like putting on one of those pedometers, okay, on your belt. You see some older people, they like to count how many steps they do. I guess it's something to fill their time as they get older, but they're counting how many steps they went. They are measuring a distance. If we were to measure displacement, it's measured from where you started from, okay? So two challenging ones, and then we're going to work on those as we go through, okay? Speed. Speed, it is how fast an object is moving, regardless the direction. So forward, backward, doesn't matter. So again, this is scalar, and 30 kilometers an hour, which is probably not very common for a lot of you that are driving, but your car will do 30 kilometers an hour. You just got to brake a little bit more. Velocity then is the vector, okay? So speed is how fast you go. Velocity is how fast you go in a direction. All right. So if my velocity is 30 kilometers an hour east, okay? So it is the rate and how I'm moving with a direction. So that's the only difference between speed and velocity. Velocity requires you to tell me which direction you're going. Speed, I don't care which direction you're going. Hopefully not backwards if you're giving me 100 kilometers an hour. All right. Last four that I want to talk about. Acceleration. Acceleration. This is when you put the pedal to the metal, so to speak. All right. The rate of change of your velocity, or how does your velocity change in a given time frame. So acceleration is how fast are you speeding up, basically. All right. So it is measured. It is a vector because you need to be either speeding up or slowing down. And the units for us would be 3 meters per second squared, or it could be 3 kilometers per hour squared. And I'll show you the math a little bit later on why the units work that way. But that is, the time gets squared when we're reporting that. So it's how fast your velocity or your speed's changing, or your velocity's changing. Average speed. It is the total distance divided by total time. Okay. So, um, speed average is distance over time. All right. And that will give you kilometers per hour or meters per second. So that's your average speed. Now your average velocity is the same thing, but it's the ratio of displacement with how much time. So V av equals displacement over time. All right. And finally, the last one is your instantaneous velocity. Okay, so this is the ratio of distance traveled at one point in time. Okay, and your speedometer is really an indicator of that right there. All right, it indicates how fast you're going. It just doesn't tell you the direction. Hopefully, you're looking out the window to know whether you're going forward or backward. But your speedometer will calculate that for you. So instantaneous velocity, it's a term. We're not going to get into a whole lot of detail on how to calculate it, just because the math goes a little bit beyond what I want to deal with anyway. But it gives you an idea. It's a term that does come up once in a while. All right. So there's the terminology taken care of and done. All right. So let's talk turkey here. So I want to go back to speed versus velocity. Okay. So here we are in a round track, and let's put the starting line down here, and it's also our finish line. All right. So it's a circular track. All right. So it's like NASCAR. They go around in circles. As long as you turn left and hit an accelerator, you can do it. So Mark ran around a 400-meter track once in 10 minutes. So some of you are kind of laughing because 10 minutes, but that's kind of how fast I run 400 meters. That's a long way. Anyway, so first one is determine the distance Mark ran. So he ran around the track once, one full cycle. All right, he started here. He went all the way around. So the distance Mark ran was 400 meters. He went one full lap. What's his displacement? What's his displacement? So remember, distance doesn't matter which way you went. It's how far you actually walked, like your pedometer. Displacement is how far are you from your starting point. If Mark returns back to the finish line, he's really gone 0 meters in displacement. He hasn't gone anywhere. He's returned to his starting point. So that's the difference between distance and displacement. Now, average speed. All right, average speed. Go over here for that. So speed, I told you in the previous slide, it's distance divided by time. So he went 400 meters, and that's from here. Okay, that's his distance in 10 minutes, which is my pace. So that means he did 40 meters each minute. So that's his average speed. What really throws people is when we calculate average velocity. So average velocity is equal to displacement over time. Now from above, we just said displacement was 0. So 0 divided by 10 is 0 meters per minute. And that's his average velocity. So that's a significant difference between speed and velocity. All right. And it comes from that connection between distance and displacement. But that's the way it works when you go through and follow the two meanings or definitions. All right. So again, it's wrapping your head around. If you're comfortable with the difference between distance and displacement, then you can kind of work your head around speed and velocity. So determine the relationship between distance and time when a truck has traveled based on the given table, which isn't there. Oh, and voila, there is the table magically appearing. Right? If you want to pause that to write that down, I'm just going to move into what I wanted to go through here. And what I want to do is, this is basically a stopwatch. So basically we take the time at time 0, and I say go, and you drive by with the truck, and I've recorded your distances here. So what we're going to do is we're going to plot it on a table. So time, and we'll put distance this axis, and we're just going to plot our points. So 0, 0. Each notch is worth 2, so 2, 4, 4, and 8, 6 and 12, 8 and 16. Okay, so here's where we have you going at a constant speed. So basically, I'm basically measuring you from a point you drive by with cruise control on. So if I was to draw a line there, okay, we see that it creates a straight line. All right, which is a double negative, but anyway, our distance is being measured here in meters. Distance is in meters, and time will go in seconds. So what is the relationship that comes out of a line? So some of you will remember grade 9 and grade 10 when we talked about slope. Some of you have blocked it out of your mind and are now screaming curses about it coming back up. But with a line, the relationship that exists in a line is that constant rate of change, or that slope. So what is the slope? If we calculate, if you remember back, slope is equal to rise divided by run. So in our case, our slope is equal to our change in distance divided by our change in time. So for this example, 2, 4, 6, 8, 10, 12 for my triangle. I just drew any triangle, doesn't matter, remember. 4, 6, 12 over 6. And if I measure 12, I'm measuring 12 meters, and time is 6 seconds. So 12 divided by 6 is 2 meters per second. So what is a measurement of meters per second, kilometers per hour? That is a speed. All right. Still, slope of a distance timeline gives us speed slash velocity, depends on what we're looking for. Okay, and it's because of the way the units worked out when we did the division here, 12 divided by 6. All right, so if you have a graph with a distance and time, you can find how fast the object was traveling. So moving on to the final slide here, a couple of quick examples. Determine the missing values. So your average velocity if you drove 550 kilometers in 6 hours. So the formula that arose from this previous page was v equals d over t. So your velocity equals distance divided by time. Now they told me 550 kilometers is the distance divided by time. So I have 550 divided by 6. 550 divided by 6 gives me 91, call it 92 kilometers, because that's what the unit is, per hour. So if you drove 550 kilometers in 6 hours, you're averaging 92 kilometers an hour. Your distance traveled if you drove 80 kilometers an hour for 25 hours. V equals d over t. I know my v this time. It's 80. I'm looking for my distance. Time is 25. So we're just using some of our grade 9 and 10 algebra skills here. Multiply both sides by 25. And when you do that, you get distance is 2,000 kilometers. C part, your time traveling, when you drove a velocity of 120 for displacement of 3,500. We know our velocity was 120. We know we had a distance of 3,500 over time. Remember, you need to flip the fractions. Put over 1. And I'm going to finish this in the next very, very short video. Sorry about that.